Okay, gang. Now, just as with adding expressions, you can only add, let's write it down, can only add or subtract like terms. So I could add 2 square root of 2 plus 5 square root of 2. That gives me 7 square root of 2. It's like 2x plus 5x. But I can't add 2 square root of 2 plus 5 square root of 3. That's already in simplest form. So once you understand that, these become very much like adding together any expressions. So we'll go through a couple of examples, and obviously the radicals present some interesting new twists. So if you look at this problem, we've got some addition and subtraction mixed in here, but what we really have are all like terms. And so we simply add them together, and we wind up with 4 square root of 2's, right? 3 minus 5 is minus 2, plus 6 will give me 4. So in this case, it's that easy to add these two together, these 3 together. So take a look at this problem. At first glance, it doesn't seem like there are any like terms, but we need to simplify our radical expressions completely. As you should remember, the square root of 8 can be simplified because 8 has a perfect square factor, which is 4. Same thing with 18. 18 has a perfect square factor, which is 9. So take a second here, press pause, see if you can work this problem out, and then press play and see if you agree with what I've got. So here is what you should have as an intermediate step. And now you ask the question, are there any like terms? Well, you got a square root of 2 and a square root of 5 and a square root of 6. Those are all different. But then you have another square root of 2. And so those two can be added together. And what we get are 9 square roots of 2 minus the square root of 5 minus 3 square root of 6. And there's our final simplified answer. All right, let's try another one. Wow, check out these numbers. But remember, we're looking at fourth roots, and the perfect fourths are big numbers. And so we would really be helped by having a list of those perfect fourths. So I'll write that list down a little bit, and that'll help you see what's happening. So that's enough to help us. So what we're going to do, excuse me, we're going to start writing these with a factored form. So 48, what does that have as a factor, which is a perfect fourth? 16 times 3. That's the fourth root. Minus 3 times the fourth root. Well, 405, that's a big one. Can you see what that's going to be? Takes a little second, but 81 times 5. Minus 3 times the fourth root. Well, there's another 48, right? I should have added those two together at the beginning, but that's okay. Minus the fourth root of 162, and that's going to be an 81 times 2. All right, so now I have those kind of written in lowest form. So now I'm going to just take out the correct numbers. So 2 times 2 times the fourth root of 3 minus 3 times 3 times the fourth root of 5 minus 3 times 2 times the fourth root of 3 minus 3 times the fourth root of 2. So this gives me 4 times the fourth root of 3 minus 9 times the fourth root of 5 minus 6 times the fourth root of 3 minus 3 times the fourth root of 2. And do you see any like terms? Let's see, we got square root of 3, and square root of 3. So if I add those two together, I get minus 2 times the 4th root of 3, minus 9 times the 4th root of 5, minus 3 times the 4th root of 2. And there we go. So there's our final answer. It took a lot of work, and it really, really helped to have a little table of knowing what the numbers are that you can take the 4th root of. Okay, so that's it for section 3. See you next time.